Hello guys, welcome to my YouTube channel. So we had been discussing our lecture on herd immunity. So today we will discuss one of the most important concepts, which is basic reproduction number denoted as R naught. So first, what is R naught? So it is the average number of secondary infections. So caused by one infected individual in a completely susceptible population. Okay, so it is the average number of secondary infections caused by an infected individual in a completely susceptible population. All right, so the examples, if we talk about examples, so for seasonal influenza, so for seasonal influenza, the R naught is somewhere around 1.3. For COVID-19 early strains, if we talk about, so the R naught was somewhere around 2 to 3. All right. So for smallpox, the R naught was 5 to 7. And measles, okay, so for measles, the R naught is somewhere around 12 to 18. So R naught is 2, for example, means the average is 2. Okay, so the average number of secondary infections is 2 caused by one infected individual. So one infected person on average is producing 2 infections in a population. So that is the meaning of R naught. So if we talk about a higher R naught, okay, so higher R naught means disease spreads more easily. Disease spreads more easily. So if a disease is spreading more easily, that means it requires higher vaccination coverage. Okay, so now in the examples, 4 examples that we have talked, you can see here from top to bottom the R naught value is increasing. So among these 4 examples, the R naught value was lowest for seasonal influenza and highest for measles. That means you need to have a higher rate of vaccination for measles as compared to seasonal influenza. All right, so next we will move on to another topic, which is called as a herd immunity threshold. All right, so what does it mean? It is the minimum proportion of immune individuals required to stop sustained disease transmission. So it is the minimum proportion of immune individuals required to stop sustained disease transmission. Okay, so this threshold value depends directly on R naught value of the pathogen. Okay, so as I have already told you, if R naught value is low, okay, so what does it mean? Fewer people need immunity. That means you require less proportion of immune individuals to stop the spread of the disease. Whereas if R naught value is high, what does it mean? It means a much larger fraction of population needs to be vaccinated. So in the four examples that we have talked about, you remember that measles was having the highest R naught value. Okay, so R naught value for measles is very high. That is why it is one of the most contagious human diseases. Okay, and it requires a 95% of vaccination coverage. Okay, so as we have talked about why herd immunity is important, it is important to provide indirect protection to individuals who cannot receive vaccines like newborn infants, pregnant women, patients under chemotherapy, organ transplant recipients, individuals with severe immunodeficiency disorders, and people with specific allergic symptoms. Okay, so real life examples, if we talk about herd immunity, so one case was about smallpox eradication. Smallpox eradication. So smallpox once killed millions of people worldwide. So, but following the development of smallpox vaccine, okay, following the development of smallpox vaccine, large scale vaccination campaigns were implemented. So, large scale vaccination campaigns were implemented. As vaccination coverage increased, as vaccination coverage increased, number of susceptible individuals declined, transmission chains were interrupted, and outbreaks became increasingly rare. Okay, eventually the disease was eradicated globally in 1980. So this is it. Another example that I can provide you is about polio control. So all of these are examples of herd immunity. So as we know, polio spreads primarily through fecal oral route. So mass immunization campaigns were developed. So here also mass immunization campaigns using oral and inactivated polio vaccines, okay, have dramatically decreased polio cases. When vaccination rates remain high, when vaccination rates remain high, circulation of the virus decreases. Okay. Hence protects even those who have not been yet vaccinated. However, if vaccination rates decline, outbreaks can reappear, and this highlights the importance of maintaining herd immunity. And the last topic for today's lecture is why herd immunity sometimes fails. So this is an important question. So first thing is that herd immunity is not guaranteed. Okay, so several factors are there that can reduce its effectiveness. So number one is low vaccination coverage. So if many people refuse or miss vaccination, then sufficient susceptible individuals remain. Okay. Number two is pathogen mutation. So like rapidly mutating viruses are there that may partially evade the existing immunity. Number three is uneven vaccine distribution. So there are certain communities may have lower vaccination rates, so this will allow localized outbreaks. Number four is waning immunity. So this means that protection of vaccines decreases over time, making booster doses necessary. And there could be a fifth solution, like fifth point, which is vaccine hesitancy. So it means the delay in acceptance or refusal of vaccines. So sometimes people do not want to take vaccines. So this could be another reason. So that's all for today's lecture. Stay tuned for more upcoming videos on vaccine technology. Thank you.